Hello, everyone. Thank you for joining the presentation of today, where we will talk about hidden energy saving in HVAC, presented by Medley expert and Blader, and sponsored by Circuit Meter. Presenters of today will be myself, Robin Lucidarm, Energy and Sustainability Advisor, and James Atkinson, Mechanical Product Engineer, Lead Certified, and other certifications. A little bit of an introduction about Medley Expert. Why Medley Expert? In the beginning, we were talking about sustainability, but sustainability is a big word, and that's why we call it a Medley solution. We can talk about heating, cooling, lighting, batteries, and so on. And to configure that for your building, it can be a very difficult situation because every building is unique. And that's why the team of Medley will contact other experts and check which solution is the best for you. And so create a custom solution which is in your budget, which is in your type of building, and we will configure a solution that fits in your configuration to make a custom solution. Our sponsor of today is Circuit Meter. And why do we promote sub-metering by Circuit Meter? Because if you have a building, there's a lot of unknown things in a building. So you have different utility sources. So first of all, why? To visualize your energy, because there's different energy. Also, don't forget, if you have equipment, precision maintenance. Because you have monitoring of every system, you can do more predict and prevent, which is precision maintenance, and have a better situation here. Automate your GSG reporting, better operational savings. Don't forget as well, because we use more and more energy, demand and response is also something important, and that's where sub-metering can visualize that. When you have a building here, you can see that there's a lot of unknown things, and sub-metering can address these individual components a lot better for your building. Why do we do these presentations? For people who joined already multiple times, the agenda is changing all the time. So first of all, we see that there's an operational carbon of 28%. There's also materials and construction 11%. This together is already a huge part of carbon emissions in the building industry, and global warming has climate change widespread and extreme impacts. But the agenda is changing all the time. We have political behaviors. For the moment, we see that oil prices are also way higher, and so the agenda is shifting all the time. And that's why we want to address the new agenda all the time and check how we can help everybody in the audience to grow in that industry. We focus now on bringing more operational savings than only sustainability. If you want to focus on sustainability, yes, having better operational savings also covers your sustainability goals. And so what should we try to do? We try to explain trends in the buildings, technology, the technology, learn from local experts. For example, today we were talking about with Blader, and you as a building owner, building manager, or engineer, you can now make better informed decisions. So that's the goal, that we try to make your life easier.
Right, so thank you for the introduction. As mentioned, I'm James. I'm a product designer here at Blade Air, and I wanted to give some introduction to a few different energy standards that can help you save energy in your buildings. I'm coming to you from Ontario, and I wanted to give a brief overview of our energy landscape. Right now, we're predicting a very steep increase in energy demand, 75% by 2050, as predicted by Ontario's Independent Energy System Operator, and a predicted 64% increase in peak electricity wholesale cost, right? So if you look at the chart on the right, you'll see that November 26 to Jan 2027 is predicted at $108 per megawatt hour, which is a huge increase. And this is really a short-term price increase. You'll see that by the end of the year, 2027, it does start going down. And this is because of a lot of development in AI data centers, increased building electrification, electric vehicles. There's a lot more demand on our grid. Now, I don't want to sound too apocalyptic because there is a plan for this, right? We have the small modular reactors coming online in the 2030s. There is currently underway a battery storage plan to manage peak demand. It's the Oneida project, but that's still in procurement phase. I think the thing to note here is that for a while, the increased demand will be outpacing the construction of new energy products. So there's going to be a short-term rise in expected, power expenditures. A quick note on the buildings. It's an estimated 30 to 40% of global energy production that is consumed by the built environment, right? So this is all the power going to our buildings. HVAC operations, so non-process loads, this has nothing to do with the actual purpose of the building itself. This is just the HVAC load of the building, accounts for 40% of the total building's energy consumption. Combining those two numbers, we get an estimate of about 16% of total energy generation is used to heat and cool and condition our buildings. So bring that back to Ontario's electric grid. The peak load for last year was 7 p.m. June 24th. So everyone's home, everyone's running their TVs, their washing machines. It's very warm, so people are cooling. That was almost 25,000 megawatts of demand on the grid. If we were to save just 5% of all building energy, we could reduce that peak load by 200 megawatts. So even small incremental changes to how we're operating our buildings, how we're using our data can have a very large effect. Now, there's things like demand response programs that will have the ISO actually turn off your cooling system for those peak demands. We're not going to talk about those because it's a little harder for institutional people to implement. It can be restrictive. So let's talk about the problem. Obviously, we could do a whole building retrofit. We could change out the cooling system for something more efficient. We could change out the building envelope for something more airtight. But these are long-term. They could be cost prohibitive, right? Installing solar panels will reduce your peak load because you are generating on site. But again, it's expensive. Maybe your roof doesn't support it, so you would need to redo your entire structure, right? It could be too long term. As we mentioned, there's going to be a steep price in energy cost over the short term, but over the long term, energy generation will rise to meet those demands. But what do we do for that near to short term? How can we just change how we're operating our buildings to achieve better energy efficiency? And at the same time, we also can't sacrifice our air quality. The more data we learn, the better we characterize how indoor pollutants affect human health, productivity, and the standards themselves are also growing more stringent as we get more data. So we can't compromise on air quality, but we need to improve our energy performance. To address that problem, let's start at the beginning with how we actually design our ventilation requirements. I would assume that most of us are familiar with ASHRAE 62.1 and the residential standard 62.2, but just a quick introduction for those who aren't. This is a standard that outlines the minimum airflow requirements for commercial and institutional buildings, right? So banks, schools, any commercial or institutional project. This is really where the design airflow requirements will come from. So there's two factors. There's first a per person and then a per unit of floor area, right? So the per person ventilation requirement is to account for things like breathing, so bioeffluents, infectious bioaerosols, so if people are sick and coughing, all that sort of thing. And then the per unit area, that's to account for building generation. So if you have building materials that are off-gassing, right, new furniture, that formaldehyde smell, different pollutants from building operations. So if you're in an auto shop, you're using lots of harsh chemicals, things like that. So it's very easy to implement, right? You just have to look up at a table, what kind of building you're using, what kind of activities you have. You can choose those variables, you plug in your population, your space, you're done. You know how much air you need to develop. And it's that simplicity, that ease of use that's led these to being widely adopted. These have been referenced by the overwhelming majority of North American building codes with very few exceptions. It's easy for an inspector to check, right? They can do the math themselves in a few minutes, make sure that everything's compliant, we're all good. It's not a standard for energy performance, right? This is an air quality standard. So this is a quick way to make sure that people in the building are probably safe, right? You're probably delivering enough air for people to be healthy, happy, comfortable, all that good stuff. But it doesn't really guarantee air quality. It just guarantees ventilation. What happens if you're in, say, a polluted environment, right? You're having a really bad smog day. No amount of ventilation is going to give you a good indoor air quality because you're just bringing in polluted air. There's also dead zones, right? If your HVAC system is improperly optimized, you're going to have pockets where air isn't properly circulating. It's not mixing, you get stratification. So it doesn't matter how much air you're bringing into the space. If it's not reaching certain zones, certain breathing areas, or it's not properly removing the pollutants, it's just guaranteeing ventilation. It's not guaranteeing air quality. There have been amendments that add, correction factors for these different things. But at the end of the day, ASHRAE 62.1 was first released in 1973. There was no sensors, there was no data tracking, right? It was, I don't want to say rudimentary because at the time it was state of the art, but there wasn't as much guarantee on the end effectiveness of these systems. So it was always designed to be a very conservative estimate, right? It's a worst case scenario, dump a bunch of fresh air in there and hope for the best. So how do we guarantee healthy indoor air and how do we guarantee better energy savings? This is where the IAQP, or the Indoor Air Quality Procedure, comes in. It looks like a bunch of scary math, scary numbers, a lot of subscripts, a lot of variables, but it really boils down to a mass balance equation. There is pollutants being generated and pollutants being removed. So pollutants are removed from air cleaners, from ventilation, and pollutants are generated by people breathing, activities like cutting, machining, cleaning products, off-gassing of your building components. So you're really just solving that mass balance equation to keep pollutants under a required level, a threshold level that has been determined to be safe for your occupants. Importantly, this allows us to actually account for the air cleaning devices in the design of our air systems, right? Normally with the VRP, the original one I showed before, you can add air cleaning devices and they may be a requirement if you're determined to have a poor outdoor air quality in your area, but you can't reduce the size or the volume of your outdoor air. And that's all air that you have to heat up, you have to treat, you have to heat up, cool down, right? That's a lot of energy. With this, you can actually reduce the fraction of outdoor air to account for the fact that your air is being acceptably treated and recirculated. The caveat here is that air quality monitoring must be included, right? You have to, at the end of the day, prove that these calculations, this theory of reducing air volume by cleaning it will still guarantee a healthy environment for your occupants. And that's something that we couldn't do before. But now I think sensors are becoming so proliferated in the industry. There's so much more architecture and options for really monitoring and validating your air quality that we can afford to be a little more stringent with how much ventilation we're actually giving to a space and still guaranteeing a good environment. Now, there was historically quite low industry adoption of the standard because it was quite, I'll say, ambiguous on how to implement it. There is 12 pollutants that are tracked, but it was up to building designers to determine the rates of generation, the rates of cleaning. So it was a bit nebulous to actually guarantee. So it is a building standard. So you can use it as a design standard to reference the size of your equipment. Most people will still size to 62.2, but with the IAQP, you can now reduce, you can actually turn down your ventilation. You can change the operating mode to account for the IAQP. So you can reduce your outdoor air fraction so that you're not having to treat as much fresh air, and then you get the associated energy savings. In 2025, ASHRAE released a calculator that you can actually plug in your variables, plug in your different zones and the expected uses, and you can track what you expect your new ventilation requirements to be. There's a variety of different results, but it's commonly that you'll see 50 to 70% reduction in your ventilation, right? So you're still providing a similar amount of air volume at the space, but the fresh air is highly reduced because we have much better air cleaning technologies now. And these are things that can be implemented quite simply without a huge retrofit. So whether it's UV sterilization, whether it's HEPA filtration or electrostatic filtration, as I will mention a little later, we have more technology to clean the air. And now we have a standard that can actually take advantage of that to reduce the amount of fresh air coming in. And because this is always guaranteed with air quality monitoring, you can be sure that you're not reducing it to a point where it's going to create an unhealthy environment. This is always with the occupants in mind. It places a more stringent emphasis on validation after the fact instead of a prescriptive standard that just says, dump in a bunch of fresh air, hope for the best. Up to 13% of total energy savings. That's because of the reduction in treatment energy, but with our technology, you can also save on fan energy. So I will take a moment to talk about low pressure filtration. So this is Blade Air's Pro Filter. It is an electromagnetic filter that is actually a plug-in device that uses an electrostatic force to trap dust instead of the mechanical force that you'd see from a MERV 8 to MERV 13 pleated filter. Our filter delivers MERV 13 performance with MERV 8 pressure drop. That is to say, you can reduce your fan energy expenditure because it's not as hard to blow air through the filter, but you're still achieving very high rates of filtration because we use a positive electrostatic force to actually trap dust in the filter, right? Instead of just relying on a passive mesh or a pleated filter like a HEPA or almost like a coffee filter. The more dense your weave, the better filtration you get, but also the harder it is to push air through it. So because we don't load as fast, because we have that coarser mesh, you can actually increase your duty cycle as well. So you reduce your maintenance, right? We can double the lifespan of a typical pleated filter, and it produces much less waste. So the metal mesh, that frame, is reusable, and you only swap out the media when it is time to change. So you're sending much less to landfill. You also have a much easier time with the maintenance itself because you don't have to lug a huge box of cardboard filters up to the roof. They're just vacuum sealed filter pads that you swap out. You can put the old filter into the bag from the new one and not have to store several pallets worth of filters. So these filters, because they're electromagnetic, we have very high performance on the ultrafine particles, right? So these are especially effective in terms of wildfire smoke because it's those carbon microparticles. They are attracted to electrostatic fields. They get trapped. We also have VOC reduction. So we have some demonstrated third-party testing that shows that we're actually able to trap VOCs as well. And this is because electrostatic force, right? Normally gas phase pollutants can't be trapped by a filter. But again, we have an electromagnetic force that is actually pulling, molecular level, pulling these compounds into the filter so they can be trapped instead of just a purely mechanical means. I'm going to hand it back to Robin. We can open it up for some Q&A.
Yeah.
Yeah, so I see a couple questions. One from Anton asking about the cost of the filter. It's about $200 for most of the standard sizes. That's with the frame and the pad. But you will see significant fan energy savings. So both the fan motor energy is reduced. You also get increased airflow, so better heating and cooling. So a typical buyback period and your return on investment is less than 2 years, just because you do have an initial cost, but you are spending less energy and the maintenance is cheaper. So the new pads are cheaper than a typical pleated filter. So the payback period is usually under 2 years, which for reference is better than LED lights. And I think LED lights at this point are a no-brainer. To operate the Pro filter, do we need to run power to the filter wall? That's a great question. So they are a powered device. It is a 24 VAC current that you need to deliver. So if you have a small air handler unit, usually we will run them right off the control line because it's a 24 volts AC. Each filter only draws 2 watts of power. Comparing that to the fan energy, fans are usually 5 to 10 kilowatts, say. 2 watt draw power from your filter is barely anything. These are static pressure. So these are low static pressure filters. And because of the electrostatic field, they also don't clog up as quickly. Because you have electrostatic fields, dust will coat the entire media evenly instead of just face loading like a typical pleated filter. As Robin mentioned, you can get filter breakdown where the front face is so clogged up, it'll actually pull the entire filter right through the frame. Chad asks, how long do they last on average? We usually say we can double the life of whatever you're typically getting. So if you're seeing 3 months of operation from a pleat, we'll get 6 months. We go up to a year just because at that point the filter needs changing. Whether you have full dust load or not, we should just really swap that out. It's been a year. What is the final pressure drop of the filter? That really depends on your system. We don't go over an inch. Usually it's about half an inch to 3/4 of an inch, but that's I will say 3/4 of an inch is a very conservative estimate because we have 8 times the dust loading capacity of a typical MERV 8 pleated filter to the same final pressure drop, right? So if you're getting 0.75 inches of water column across one of these, you will have almost a kilogram of dust in the filter. So typically we would replace over time instead of final pressure drop because they are low pressure. So it's not a pre-filter. This is a complete replacement, right? So the metal frame will drop into your rack wherever you have a typical pleated filter. It's just a 1-for-1 replacement. We have had cases where people will replace a bag pre-filter and a MERV 13 final filter with just these, and they actually see better performance. So because we have that electrostatic field, this is a powered device. You're able to get much higher filtration potential or filtration performance with a lower pressure drop. And because of that high dust loading, you can actually combine your bag and final with just this Pro filter.
And to add there, so out of my experience, I was talking to somebody who's in the middle of an implementation of an ISO 50001 for larger corporations, where they need to report their scope 1, scope 2, but they're seeing more reporting of scope 3 emissions. So operational emissions will go down because you use less energy with these filters, but scope 3, we're not fully replacing the filter, but only the pad. So you can see even there, you can help additionally with your energy management system and your emission reporting as well, which is a byproduct of helping with operational savings and GHG savings.
So another question, let's say an RTU uses 2-inch pleated filters. Would this be a straight swap? Absolutely. So these are like for like. You give us the size of your current filters, we will return you a Pro filter that fits that exact spot. We have a 1-inch and a 2-inch model. So the one shown here is our 2-inch. And you will just drop them in. The only difference, you have to plug them in. So if you do have more than, let's say, 12 filters, we will usually just send you a transformer to go along with them so that you're not pulling too much load off of the control panel. Smaller filters, let's say 6 or lower, we just go right off the control line because that's 24 volts AC. Can replace the MERV 13 bag filter in kitchen exhaust filter units. We have done that. I think there was a fast food restaurant that used our filters with quite good results. I am not as familiar with the standards for kitchen. I'm not sure if there's a specific requirement for, say, the grease because it's from a kitchen environment, but we have done it. Can you talk about wildfire smoke and what control sequences are typical when implementing the Pro filter? Great question. So we've had a independent study running our filters head-to-head with a MERV 13 in a wildfire event. I think it was in North Carolina. It was a couple of years ago when the wildfire smoke from Ontario, Manitoba was coming down south and reaching the States. And we had very good feedback, right? So we actually didn't have to change the operation schedules. A lot of places will actually shut down, right? They have the fire dampers, they will shut down the outdoor air. We were actually able to keep drawing fresh air and still operate quite well and not have to change the filters weekly, right? The MERV 13, I think they had to change more than once a week because they were getting so clogged up with the particulate. Whereas ours, we could run for a month, actually, because we have, again, 8 times the dust loading capacity before they need to be changed. And because they have that high performance with submicron particles. Does this filter work with engineered air makeup air units? Anywhere there's a pleated filter, it'll work. So if you have a 2-inch, 4-inch, whatever the standard size, we can make it. We can go up to 36 inches alongside. Anything larger than that, we just split it up into 2 filters. Do you have any certification? Yeah, so we are tested with ASHRAE 54, Appendix J, MERV 13A tested. I will say one caveat there. The MERV testing is really first pass efficiency is what they are weighted towards. So you get, one cycle, they dump some dust in the air, whatever that comes out, that's what your performance is. In real performance, our filters actually outperform MERV 13 because electric field, basically dust will start to agglomerate and stick to itself because it becomes statically attracted and it polarizes. So you'll actually get every pass through the filter will improve your air quality, right? Which is in opposition to a standard pleated filter where really a particle gets through or it doesn't. In our case, every time you recycle air through that, you get more filtration. So we actually quite outperform MERV 13 in a real case, but obviously for testing purposes, there's a standard, you get one shot, and that's it. So absolutely, yeah, we have that data. We can send you our testing data if you need some confirmation. Any questions about the IAQP versus standard 62? I know I went through it quite fast just for timing. I think the main thing I wanted to stress is that standard 62 is a prescriptive standard that really just guarantees ventilation. It doesn't guarantee really safe indoor air. Whereas the IAQP is a more practical, data-driven procedure that after you've designed your building with ASHRAE 62 for, let's say, code compliance, you can then reduce your airflow by actually tracking the real pollutant concentrations in your building. And then basically you're titrating your fraction of outdoor air to see what you actually need to dilute the pollutants and make sure that there's a healthy space. I think that's really distilling the information. Quentin asks, how are these filters powered? So it's just a 24 volts AC power line. So it's just a small 3.5 millimeter jack, like you'd see with a standard sort of power plug for a phone charger or what have you. And then we have a power head. So you see at the top there's that black bar with the green indicator LED that will step up that power to 8 kilovolts at the media pad. And the media pad is insulated. It's a dielectric material. So it will polarize the media, which means that each media strand will generate its own electric field and will trap dust statically. Is there a maximum airflow rate where the Pro filter would not work? We size them, or we test them to, I think it's 400 FPM standard. We wouldn't really want to go over 500, but that's a pretty conservative estimate. That's typical of most filters. It could be 492 FPM. It's the ASHRAE standard velocity that we test at. We don't like to go over 500 FPM. And if you need higher than that, we would recommend something else like a V-Bank, one of our other products that has stacked filters for higher airflow performance. If you have any more questions, you're always welcome to reach out to the team.
Yep.
And feel free to reach out to any of us. Myself, I'm a product designer, so if you have any technical questions, I'm happy to do a lunch and learn. I wanted to keep this webinar more general and not so specific to our products, but if you have any questions, if your team wants to learn more, reach out to me and I'm happy to do a lunch and learn with the team. I'm always a fan of talking filtration.
Well, yeah, since there's no more questions coming, I would like to thank James for speaking, the audience also, thank you very much. Thank you for presenting today. Thank you for our sponsor Circuit Meter as well. And if you have any questions, feel free to contact us again with your questions. Thank you and see you in the next presentation. Bye.
Thanks for your time.